This next stoichiometry problem is going to be using molarity. So we can take molarity and we can use it and write it in a different way and use it as a conversion. So this is volume of a gas, but now we're talking right now about a volume of a solution. So if you don't have these parts on your mole map, I would put them in. So moles per liter, this is the molarity. And here we go 1 liter over the moles. So this would be really 1 over the molarity. So let me show you how that works. So we're going to do this question right here. Oops. So when I do the question, this first question, they want to know how many milliliters of 0.25 molar hydrochloric acid will be needed to neutralize 8.97 milliliters of 0.15 molar sodium hydroxide. So here's our reaction. It is balanced. When you have a problem like this, we've got milliliters and the molarity of the sodium hydroxide, and then we have the molarity of the hydrochloric acid, and we want to know the milliliters. So when I do a problem like this, I don't want to start with molarity, I'm going to start with volume. So I'm right here, and I do need to have it in liters. So I'm going to do that as my first step. You could just move the decimal if you want, but I'm going to show it. So there's 1,000 milliliters in a liter. So now I'm going to use this number. So this 0.15 big M is really 0.15 moles in 1 liter. So I'm going to put the 0.15 mole on the top and the 1 liter on the bottom. So 0.15 moles of NaOH are in 1 liter of NaOH. So my liters are canceled and I'm at moles of sodium hydroxide right here. Now it's a mole-mole problem. That's my stoichiometry. And I'm switching over now to the hydrochloric acid. So 1 mole of hydrochloric and 1 mole of sodium hydroxide. So those ones came from up here. So right now I'm at moles of hydrochloric acid, and they want to know my milliliters. So I'm going to end down here in liter, and then I'm going to go to milliliters. So I've used this. Now I'm going to use the 0.25, which really is 0.25 moles HCl in 1 liter of that solution. So now I'm going to put the 0.25 on the bottom and the 1 liter on the top. So my moles cancel. I'm right now right here in liters of hydrochloric, and they want it to be in milliliters, so I could easily convert it back. I know there's 1,000 milliliters in a liter, and now I can just calculate this. And when I do, I get 5.38 milliliters. Here's another problem. They want to know the concentration of hydrochloric acid. And so this one's a little different. I have 25 milliliters of 0.15 molar strontium hydroxide. And they want to know the concentration of hydrochloric. So they're really asking me to calculate the molarity. So first thing, you do want to make sure it's balanced. And then you're going to start with this volume that you know the molarity of. So 25 milliliters of strontium hydroxide. So I'm really going to start down here again I know I have to be in liters to start in the mole map, so I'm going to convert it. You can just move the decimal 3 places if you want. So right now I'd be in liters of SrOH2. So now I'm finally ready to use the molarity. The 115 molarity really means that I have 0.115 moles of strontium hydroxide in a 1 liter of that solution. So now I'm over here at moles of strontium hydroxide, and I'm going to switch over to the hydrochloric acid. So this is just my regular mole. I'm going to put the 2 moles of HCl on the top because I'm trying to go to that. And then I'm going to put the 1 mole, because there's really a 1 there, of strontium hydroxide on the bottom. And now I'm going to stop and get my moles because they want molarity, and molarity is not something I can directly convert to. But if I have the moles and I have the liters essentially, then I can calculate molarity. So when I do this calculation, I get 0.00575 moles of strontium hydroxide. And then just to calculate molarity, I'm going to then take those moles and I'm going to divide them by the liters of, sorry, this is not moles of strontium hydroxide. This is moles of HCl. So I'm going to calculate the concentration of the HCl by taking the moles of the HCl divided by the liters. And the liters, I'm just going to move that 3 places to the left. So when I divide 0.00575 by 0.0326, I'm going to get 0.176 molarity. So this problem is similar to the previous one, so you might want to try solving it before you watch the solution. But if you're paused and ready and you've tried it, you'd first of all want to start with a balanced equation. And then the question is, they want to know concentration of this carbonic acid. So they really want to know molarity. And they're going to, it takes 14.5 milliliters of this carbonic acid to neutralize 57.0 milliliters of the sodium hydroxide. So I'm going to start with, again, I don't ever start with molarity, and I do want to start with the volume of the one that I do know the molarity of. So I'm going to start with 57 milliliters of NaOH, which is down here. And then, before I can start on the mole map, I do want to convert this into liters. Now I'm ready to use my mole map, and I'm going to use the molarity to get to moles. My molarity is 0.548 big M, which means I have 0.548 moles of sodium hydroxide per 1 liter sodium hydroxide. So now in the mole map, I am right here, but I'm not interested in the sodium hydroxide. I'm interested in the carbonic acid. So I do need to do a mole-mole ratio to switch over to this. So 1 mole H2CO3 for every 2 moles NaOH. So I'm going to stop right now to get those moles, and then I'm going to do molarity of the acid by taking the moles of the acid over the liters of the acid. So my moles of acid for this question are 0.0156 moles. So I'm going to put that on the top, and I'm going to divide it by the volume of the carbonic acid, which is 14.5, but I need to convert that into liters. So 0.0145 liter. So when I divide that, I get 1.08 mole per liter, or molarity.